Good afternoon. Let me start with kind of the well, I'm not sure if it's the most important thing, but there's a few points attached to it. And that is homework number 4, second to last one. And on this one, let me talk a little bit about the evaluation part. So as you normally would have, we're going to have your 7 users. Let me just double check. I'm recording. I'm not sharing my screen though. Good that I checked. And that would be this one. No, I'm not really. I'm actually maybe too close to my phone. I just have a laptop sitting in my lap, pretty much. Is it any better now?
I can see it, Dr. Tiddenauer.
Okay. Just talking.
Sorry I was a bit late.
Oh, I see. Echo. Maybe because I'm too close to it. Maybe I'm too close to it, not too far away. And so um, hopefully it will adapt to it because I think they have, like Blackboard has some echo canceling stuff. And now you can see the screen, and so it's the evaluation of homework 4. And I had somebody, uh, John, I'm gonna mute you because we can hear you.
I
Some
apologize.
noises. Sorry about that. I know it's rude, but it's better this way than to kind of let it go. Okay, so on this one, first thing first, this is, again, I said it a few times, this is the most objective kind of assessment that you can give and you should get this semester. So on the criteria for review, we're just gonna go by 4 points if all 3 graph goals for drawing graphs are enabled. So basically we have no intersections, we have all the links or edges are straight, and then there is no visible difference between the length of each uh, edge or link. Again, edge and link is, mathematicians will call them edges, and links would be like if it's a network. So both are the same thing. Um, just follow this. I don't know if this graph was planar. I'll figure it out once I kind of look at your submissions. But if it were planar, then if it wasn't planar, I would go ahead and add one to everyone. So that's already built into the system. And then there'll be 3 points. So you can have all 7 people get a 4 this time. There is no limit on how many 4s you can give. There is no limit on how many 3s you can give on this evaluation. Because because I have an objective criteria, I don't have to put any kind of limit on it. So 3 points if we have only one intersection or one of the links is unusually long or short. So almost all goals, I think probably 3 is almost always possible. 2 points if we have multiple violations. I kind of left this a little bit up in the air. I didn't say 2 or 3 or 4, but it's multiple. So here's a little bit of subjectivity on how where you're going to give a 2 or where you're going to give a 1. But it shouldn't be that much subjectivity for a 3 or a 4. And then everything else is kind of things that were not good. Um, Here is where I see, and I don't want to, but I see it. Um, if somebody has an incorrect graph, they're missing nodes, they're missing edges, they have extra or too few or the wrong nodes are connected, just make sure you say incorrect draft. I will deduct points basically if you don't find it. Spend a little bit of time to go through the 7 things, and that time is really probably in the order of minutes per each, not even 10. And make sure you find those, because otherwise you're going to lose points for not finding them. If I have to do it, if I find them and they're not there, so those are kind of the main things. Um, Rarely I get into a not a no link diagram. Again, I try to make it very clear in the beginning when the assignment was posted. I want a no link diagram, no other way of graph visualization. And the other thing is kind of straightforward in there. So if I were to just make sure you give me uh, these words, I'm drawing a blank on how they're called, redundant. So I want that redundancy if something happens, random or average and so forth. So I can check the points for 1, 2, 3 that it corresponds to what they need to be. But the most important part about all this is that you can give an unlimited numbers of 4s or 3s or 2s or 1s. There's no limit. It's whatever you have in front of you. It should tell you what the points are there. So, like I said, it's the most objective way that we have so far. While we're still at homework, I'm not sure I showed you this, but I have. Let me, like I said, it'll be a lot of stop and start and stop. About homework 3, I have it's a engineered example, but I can show you what happens when we do aggregate data. And maybe sometimes I think Tableau or maybe even Power BI tries to aggregate data. So I'll share my other thing here. Okay, so here's an example. The data set, I think it's every 3 months. So let's say that that's a store that sells something, and then that's another store. So we're measuring a value on this side on column A and a value on column B. And we're trying to look for correlation. Is there any kind of correlation between them? So as you can see, when A is 1, B is -1. When A is 2, B is -2. When A is 3, B is -3. So it appears pretty obvious that there's some inverse correlation. When A gets big, B gets small. Same thing happens if we go back to, so this may be a trimester, and then this may be another one. So when A is -3, B is 3, and so forth. So there's an obvious negative correlation between these numbers. And yes, I generated them, or I came up with them more or less out of, but it's possible to have a set of numbers that are inverse correlated, just like that. If you look at this chart, it's what actually shows that number, and what you would expect to see is that, and by the way, this kind of charts that put the X and Y together, it's that scatter plot is maybe the best way to show that. I didn't want to influence any kind of reviewing, and I didn't say it loud. It wasn't recorded in the pre-recorded stuff, but I didn't say it live in the fresh recordings. But you can see that it's a pretty clear and obvious inverse correlation. We go with this secondary diagonal on them. And then the other thing I've done here is I went ahead and started aggregating. So I took, not every quarter, but every half a year, and I made a number, and then I made a number from here. And so if you go through all of these, that's kind of what we're looking at. Just FYI, kind of going through a couple of them. No, don't want to change that. you can see how I took the numbers and aggregated them every 6 months. And then this thing, and I didn't want to select all of that, sorry. So these 6 numbers were plotted here. And as you can see, it kind of shows a pretty strong positive correlation between the numbers. So I just wanted to point out that sometimes we plug in 120 values into Tableau, and Tableau decides to aggregate every 10 of them. The result may not be necessarily showing us the exact correlation if we're doing that visually. And maybe Power BI does the same thing and so forth. Maybe they don't. Maybe 120 is a small number and they would plug it in every value. But trust me, there is one number. So maybe 1,200. If we plug that in, then one of these automated visualization tools is going to start to aggregate them. And what I was trying to demonstrate here is that we can go from an obvious inverse correlation between those two numbers to one that shows positive correlation. This is not a problem only with scatter plot matrices, but I ran into it while I was doing this homework and I put it together. The example that I ran into wasn't that great as, I mean, that clear as this one, but it many times aggregation may lead to something like that. We don't see the individual relationships. They get all clumped together. So again, that was homework 3. I wanted to point it out. I don't think I've done it in class. If I've done it, I lost my memory pretty quickly then. But I wanted to have this done. And before we go any further, let me kind of go through the rest of that. So that was homework, and I'll go back to the quiz. I need to share a different thing. It's coming up. Okay. So let's kind of, as usual, I'll go through the quiz. And then I can change this mode. So that's the last one. It was right here. So this is in a graph visualization, a circular layout would have all the nodes be in a circle, and then the edges or the links kind of go through the middle. They can form, if there's 100 nodes and we have 500 of these links going through the middle, they might still form a hairball, what I call a hairball, on a load link diagram. The intersection is not necessarily reduced. The only thing that's really clear on a circular layout are the nodes on the outside. All the nodes are the outside. There's no nodes inside. So the nodes, or they form a circle, and then the edges kind of go inside. So there's definitely many times, in an average, in a random average graph, there will be intersections. And also there may be that some of these nodes are connected to some of the nodes that are right next to them, and others are connected to nodes that are way far on the other side of the circle. So this circular layout doesn't really do much for the edges. They can still intersect, and they can still be short or long, and so forth. So really the only advantage is that the nodes are going to be clearly shown. Then there was one of those kind of, it was an older paper trying to look at a telephone network, and there was an earthquake on the East Coast, and then they were cutting the middle edges. So instead of showing a link between all of them, they would just show the beginning of a link and then the ending of a link. So the problem there, that's kind of, it's going to be hard to find the node, especially if we have something like Chicago, where there's a lot of edges going out, fanning out from Chicago, and a lot of edges fanning into San Francisco and Los Angeles, and we won't be, or something in between there, like Salt Lake City, and we won't be able to really connect them together because we cut away the bulk of them in the middle to avoid hairball. But it's a little bit of a drawback. We avoid the hairball, but it's going to be hard to. We avoid the intersection between edges, but it's going to be hard to find connecting links that are shooting in the same general direction. So in a database, it's going to be from two, and then there's a lot of programs that do graph visualization that would accept these from and to. So it's not only in a database, but the reason in a database is that we cannot store them as an adjacency matrix because databases like to have the number of columns fixed. And having a from to solves that problem. And many of these can actually figure out the names of the nodes based on what we put in from and to. We can say from 0 to 3, or we can put from Anne to John and so forth. So they can infer the name of our nodes from what we put in there. So in the London subway, the only thing that's not checked here would be the reduced intersection. If we are in a subway network, we want to know where things intersect because we want to be able to maybe change trains, go from one of the trains to the next, and so forth. So they try to reduce the bending, they try to reduce the length variation. Again, in a subway representation, you will see that the distance between stations tends to be almost the same. That's not necessarily true, but you're underground, so it doesn't matter that much. You're not going to get out or have to walk it or anything. So that's pretty much, I think, the correct answers here. Let me see if I lied, if I remember correctly. And it feels like those were the ones for this week. So let me go back to this mode. Very quickly, I'm just going to scroll over the grades so you kind of know where we are. Still working on homework 3. Hopefully this week I'll have it done. And also still working on homework 5. I'm trying to figure out a way to not make it too technical or too difficult to conceal your identity and so forth. I've been running into that issue. But I should have it, if not this week, early next week. Oh, I'll have it this week, actually, in the homework 5. So the theory recap, I'll talk about them a little bit later. I think the quizzes, I kind of updated everything until today. And I haven't updated my presentation of scholarly articles or the demonstration, but I went and put the project out there. Everybody should have a 5 at this point. If I remember correctly, everybody does have a 5, which is the maximum point only for the proposal at this point. And so if you're a graduate level student, that's kind of your max would be 21.2. If you're undergraduate, 27.8 is the max at this point, given that, give or take based on the scholarly articles for graduate student and the demonstration of visualization tools. Okay, so the other thing that we're covering today looks like we're finishing up the visualization of relations. That's graphs, but also relations that are not binary. So that's kind of going to be at the end of lecture 6. And then we're moving into visualization of trees. Lecture slides should be up to date. So I already checked this one, lecture 7. Let me see if it pops up more or less correctly. It looks good. There's some, oh, this one, they stopped working apparently. So you won't be able to access them. It's not critical, but with some examples of visualization. And so those are the lectures. Good to know. They're not going to do much. Quiz already went over it. Homework already went over it. Project, please keep working on it. I'm not asking much right now, but towards the end of April, so starting April 21st, and probably it's going to take us 2 class periods, we're just going to have a progress report. So that's going to be more up. It works a lot better if we're doing this live, uh, online, and I'm able to kind of steer the direction rather than be in a video recording. So I'm not really doing, I'm not looking for a video recording for that one. But if anybody has trouble being present on the 21st, 23rd, let me know. So that's what's coming on the project. So we are in the middle of the demonstration of visualization tools. We have team C and D going on. I think I covered A and D last time. And that's pretty, and article presentations are ongoing as explained here. So we should have one more, and I think I owe at least one of these. I haven't had time last time, from March 31st. So that's pretty much the end of announcements. Let me stop the recording.